The relevance of research. The question of optimization of parameters of technological process, TP, of magnetite quartzites, iron ore, beneficiation in industrial conditions of the mining and processing plant, MPP, for the purpose of definition of settings of regulators as a part of intelligent control system, X, is considered. The multidimensional and multi-connected mathematical model of TP, which is obtained as a result of the identification procedure using the neural network approach, is considered to be known. The relevance and general formulation of such a task is presented in the works of many authors. Various modifications of gradient algorithms are now mainly used as search methods for multi-factor optimization of technological functions of targets, optimal and adaptive automatic control systems, ARCs. However, it is well known that in the case of poor conditionality of the optimization problem, which is typical in the case of an attempt to approximate technological functions, especially in non-stationary processes, there are some problems with the coincidence of the extremum search process appear. A good enough alternative to this is the use of intelligent approaches. Classification, control and evolutionary calculations. 2. Purpose and objectives of the work. The purpose of this research is to develop a generalized algorithm of intellectual classification. In the result, it is necessary to build a division of the feature space into recognition classes. The X. Let the following categories be known in advance. 1. An alphabet of recognition classes for technological situations of a set. 2. A training matrix of the type object property, which characterizes the MTH state of X in the form. 3. Statement of a material and results. Based on the above statement of the problem, the next procedure of intellectual classification will have the following stages. 1. The algorithm of intelligent classification begins to work in case of a special situation, that is, none of the following conditions are met. 2. The main cause of special situations is perturbations caused by constant fluctuations in the quality, composition and properties of primary raw materials. The peculiarity is that these effects of MPP are almost impossible to measure accurately enough during the TP in real time. For this purpose, the corresponding values of the input perturbations at the previous step are predicted.
3. To implement the classification procedure, it is necessary to form a sample of data for training of the classifier. Such a sample is formed on the basis of records of the technological database, which is constantly updated during the TP. Therefore, to improve the speed and quality of training classifier with technological database dimension DB records is selected a limited cluster with the number of records. Therefore, with this in mind, the size of the cluster for classification under TP beneficiation will be. If this amount of information is not in the technological database, for example, at the beginning of the ICS, the classification is impossible. The selection of the specified number of cluster elements from the technological database is by the method of the nearest neighbors based on the analysis of vectors with a minimum value of the Hamming radius. 4. Synthesis and training of the classifying neural network. Artificial neural networks today are one of the most effective means for automatic classification and clustering due to their sufficiently flexible learning capabilities and generalization properties. 5. The main task in the course of classification, or classification optimization, of the current technological situation is the final choice from the cluster of the best vector. Therefore, on the basis of these conditions we obtain 6. Making a final decision on the suitability, or unsuitability, of the classification results. For the successful implementation of the automated neural network classification procedure, the following conditions must be consistently met. The cluster for parameterization of the classifying neural network must contain not less than the vectors from the technological database. If the precondition is fulfilled, it is necessary to check the quality of classification on the basis of calculating the value of the maximum measure of control tolerance fields phi normalized recognition features defined, 2, and allowable forecast error, which according, 11, where, are permissible values of tolerance fields and forecast errors respectively. It is finally checked whether the obtained classification solution can satisfy the global criterion of type 9, especially by constraints, second and third local criteria. 7. In case of successful classification according to the algorithm, the class closest to the ideal development of the technological situation according to the global criterion is selected as a potential solution. 9. 4. Conclusions. The analysis of results of computer modeling allows to make certain generalizations in the form of such conclusions. 1. Intelligent classification using multi-layer neural networks and preceding cluster selection of the training sample while ensuring the appropriate number of cluster elements allows to determine the vector of settings and predict the TP beneficiation with satisfactory accuracy, which relative error does not exceed the average normalized tolerance field within 4 to 4.5%. 2. The results of computer simulation using neurosimulators such as NeuroSolutions, NeuroShell2 and Genetic Optimizer Type Gene Hunter proved that the developed algorithms and control principles using evolutionary optimization methods, genetic algorithms and automated intelligent classification can be applied to the practical implementation of modern ICS in conditions of complex multi-stage TP to determine the required values of the setting.